Yeah. Hi everyone, and welcome back to our tutorial series. Thank you all for joining us this evening. My name is Toma. For those of you who have been with us across the series, thank you for coming back week after week. We've been together for the past 4 weeks. And for anyone joining for the first time tonight, welcome. This is week 4, final session in the Responsible and Ethical AI in Practice series. A quick reminder that the session is being recorded and will be shared on our YouTube channel. If you have questions during the talk this evening, just drop them in the chat and we'll get to them in the Q&A session at the end. Or, at the end, you can also raise your hand or mute yourself and ask your questions. Right. So over the past 3 weeks, we've heard about, why AI projects fail, how to scale them, how to spot bias in AI systems, and what it takes to adopt responsible AI inside a large organization. Tonight, we are going from strategy and governance and all that good stuff into something very concrete, the actual architecture behind AI-powered decision-making in one of the highest stakes industries there is, the financial services. Our speaker tonight is Vijaita Gupta. She's a senior consultant at Deloitte and a data analytics professional with 13 years of experience in enterprise data platforms. In enterprise data platforms, financial services, and decision intelligence. She is passionate about applying AI to real-world problems, from fraud detection and risk analytics to data-driven product innovation. Our session tonight is called From Data to Decisions: How AI Powers Fraud Detection and Financial Intelligence. She'll be walking us through how enterprise data pipelines collect and process large volumes of transactional data, how machine learning and decision intelligence systems use that data to detect fraud and identify suspicious behavior, and how the architecture behind modern AI-driven decision platforms actually works in practice, from data ingestion, feature engineering, through to model scoring and real-time alerting. So please join me in welcoming her. Vijaita, over to you.
Thanks, Toma. Thank you so much for the wonderful introduction. From data to decision, how AI powers fraud detection and financial intelligence. And good evening, everyone. Thank you so much for your time, and thanks to Women in AI for giving me this opportunity. And before we dive into, financial crime and the role of AI in modern investigation, I want to briefly, introduce myself and explain why I'm passionate about this topic, this particular topic. So I have spent more than a decade in, working in compliance technology, financial crime investigation, and data analytics within large financial institutions like Barclays, Wells Fargo, Citibank. Throughout my career, I have worked on, designing and delivering technology solutions that help banks detect suspicious activities, investigate potential financial crimes, meet regulatory obligations, and ultimately protect customers and the financial systems. So, Toma, can you please move on to next slide? Yeah, so basically, if you are from data engineering background or from ETL background, you can, kind of have understanding from seeing this particular diagram that how exactly the ETL works. So in the left side, if you see, we ingest large volume of, transaction data. And in between, there's a transformation layer, where we do data profiling and transformation. And in the end, there's a target, which may be anything. So right now, for particular financial, fin crime intelligence, I'm just taking an example of Contexa. So Contexa is a tool that is, that is one of the decision intelligence tool in the market. There are various tools in the market like Neo4j, Contexa, some tools from Palantir Technologies. So I'm just taking one example, just to simplify our use case. Now the slide you see here is an example of one of such, project from my experience. At a high level, bank received enormous volume of information every day, from card transaction, account transfer, customer profiles, KYC records, sanctions data, and alerting system. The challenge is not the lack of data. The challenge is connecting all these pieces together quickly enough to, identify potentially risky behavior. Now, if I talk about, this architecture may look very technical, but the real objective is quite simple. How do we identify the suspicious behavior? So before I, dive into such architectures in detail, I would like to let you know about the kinds of fraud we have, in place currently. So Toma, please go to the next slide, please. Yeah. So you must be aware of, these kind of frauds like identity theft and takeover, payment fraud, investment and security scams, and then authorized push payment fraud and online social engineering fraud. We must have, got at least one of these, in our mobile phone or in our, usual social engineering app or something like that. So these are frauds. Now, Toma, can you please move on to next slide? Now, financial crime is broader than fraud. Fraud is visible. Now, financial crime is systematic. And the two overlap, but they operate at very different scales and require different detection strategies. Now, you already know these kind of frauds. Now, there are few other subjects that you should be aware of. That is AML, ATF, which is sometimes called as CTF. AML is anti-money laundering. ATF is anti-terrorism fraud. Anti-terrorism financing. And then there's sanction evasion. And then there's trade-based money laundering. So, Toma, please go to the next slide. Yeah. Now, what are sanctions? So sanctions are restrictions imposed by governments or international bodies to influence behavior, protect national security, and respond to activities such as terrorism, nuclear activities, or serious human rights abuses. Now, example of such, sanctioning authorities include United Nations Security Council, European Union, Office of Foreign Assets Control, Treasury Office of, Financial Sanction Implementation. And a sanctioned country is a country subject to sanctions programs that may restrict, they're not allowed to trade, they're not allowed to, do any financial transaction, they're not allowed to do any investments or shipping or any kind of, technology exports. So these are, before deep diving into further more topics, I just want to, have everybody understand that, okay, this is something to be aware of if we are talking about the financial crime intelligence. So Toma, please go to the next slide. Okay, so now we are going to talk about AML and ATF, which is also called as CTF, anti-money laundering and anti-terrorist financing. So they utilize shared data monitoring infrastructure, but their operational objectives are completely opposite. AML focus is backward looking. The goal is to detect and stop dirty money. And ATF focus is forward looking and highly time sensitive. The source of funds here can look of, completely legit, like clean business profits or donation, but the intent is to fund future malicious acts. And this requires stringent real-time sanction screening. So yeah, this is AML and ATF. Now, Toma, please go to the next slide. Now, another kind of, financial crime is trade-based money laundering, which is estimated to be one of the largest methods of laundering illicit funds globally. Detection requires connecting trade data, payment flows, and entity networks. Now, these signals rarely trigger a single alert. The risk only becomes visible when data from multiple sources is linked together. Yeah, Toma, can we go to the next slide, please? Now, how a fraud detection system actually works. Behind every approve or decline decision is a pipeline. It runs in a milliseconds. Now, each step introduces both capability and risk of errors. Now, understanding where decisions are actually made and when errors are mostly like to occur is what separates well-governed system from poorly managed ones. So it's all about governance, and it's all about, pipeline taking care of each and every, what to say, like alerting, calculating the risk score or alerting, and there are sometimes there are human intervention involved. So we'll go into detail in the next slide. So Toma, please go to the next slide. Now, the evolution of fraud detection system. We started with rule-based system. The code was just if then else logic. So that was fast, auditable, but fraudsters, they learn the rules and route around them within weeks, right? And then we moved to statistical ML models. Then we moved to graph-based systems, and then we moved to hybrid decision systems. Now, each generation of fraud detection solved something the previous one could not, and each also introduces new limitations. So no single approach is sufficient. The question for any organization is which combination is proportionate to the risk profile and operational maturity. Like, so it's a very subjective topic. It depends on uh, organization to organization that what kinds of case they're handling and such kind of detection system they would use. Tumap, can we please go to the next slide? Now I'm going to introduce you with this topic, which is called as decision intelligence. Decision intelligence is the discipline of turning the data into better decisions, um, like in real time as well, and with human oversight built in. Rather than a single AI model making a call, it is layered system where each layer has a clear job. Now, let's take an example of Contexa, which is one of the decision intelligence tool. It refers to as contextual decision intelligence, and it understands not just what happened, but who was involved, how they are connected, and what the context say about the risk. So if you see various layers, there's data layer, which is raw transaction, there's identity layer, which uses entity resolution, which we'll cover in the next slide. And then there's a graph layer where there's a network linkage and relationship mappings, like how every person is related to each other. When I can be any person who is doing a large amount of transaction which looks legit, but I'm transferring it to multiple members with small chunks, and then finally everything is going to merge to another target person. So how will we create that linkage? It's what the graph layer does. Intelligent layer, where ML models and business rules are set up, to raise the risk score. And then there's a decision layer, whether we should be blocking that card or blocking that account or not. And then there's a governance layer, because sometimes it happens that there are false alarms. I might be very innocent. I'm visiting some country for the very first time, Singapore, and according to the bank data, I have never visited that country. So it will raise an alarm. It will say that this girl has never visited that country. Maybe her card is stolen and that is being used in some other country, and they will just block my card. And I'm in the soup. Like, I'm innocent. I don't have anything to do with any such kind of activities, but there's no fraud happening with me. So such kind of false alarm should be reduced. So for that, we have the governance layer. So yeah, Toma, can we please go to the next slide? Okay. Now we will talk about identity resolution, which is the foundation layer. If you see, I have written there like the same person appears across your system under different names, emails, addresses, and account numbers. Fraudster exploit this fragmentation deliberately. So John Smith can be same as Jay Smith, can be same as Jonathan Smith. So identity resolution is how a system figures out that two records, even they look slightly different, actually belong to the same real person. Think of it like a detective connecting dots across different databases to build one clear picture of who someone really is. So tools use probabilistic matching. Instead of needing an exact match, the system calculates the likelihood that two records belong to the same person based on the overlapping signals. Now it then merges those fragments into single unified view of that customer. And second thing is graph intelligence. Graph intelligence is the ability to look beyond a single customer or transaction and understand the web of connections around them. So instead of asking, is this account suspicious? A graph-based system asks, who is connected to this account? And are any of those connections risky? So DI tools build these relationship networks dynamically, linking people, account, devices, transactions in real time. All right. So we can move to the next slide. So this is the end-to-end process of graph-based, entity resolution. So we ingest the data. So we take messy, siloed data, siloed as in isolated data, which has no connection between them. We clean it and we convert them into a uniform format. Then we do the smart blocking, to prevent system from crashing under billions of comparison. We use search index, which is Elasticsearch Lucene, to quickly group similar looking records into smaller buckets. Then we do scoring. Like we look inside those buckets and use fuzzy matching to catch typos while applying mathematical weights. For example, matching a rare passport number adds high confidence, and matching a common name adds low confidence. And then we do the dynamic graph aggregation. So Apache Spark connects these matching pieces into live network graph on the fly. So this allows users to dynamically toggle between loose rules to catch fraud in real time. So yeah, this is how the architecture looks like. I'm really sorry if it is too much information in a slide, but this is what I could, do my best to, show exactly what the architecture looks like inside the, graph-based entity resolution. So yeah, we can move to the next slide. Now, bias is a huge risk in any financial services. Now, how any decision intelligence tool ensure fairness, explainability, and model reliability. So they ensure trust in decisions by combining data context, network intelligence, and continuous monitoring. Now, first we'll talk about bias and fairness checks. So how a tool makes sure that there's a fairness in their decision. So they compare risk decision across customer segments using consistent network context, and then they do parity validation. They ensure scoring and alerts behave consistently across similar entities in the network. And then talking about the feature and signal attributes. So every risk score is explainable through connected data like transaction and relationship behavior. So if anybody, ask about, why this particular activity was alarmed as suspicious, the system designed should be able to answer, should be able to backtrack that why it was raised as an alarm. And then drift monitoring tracks changes in data patterns. Example, there is a new kind of fraud that has been emerging. So drift monitoring is something, to catch those kind of rings. So yeah, this is about the uh, ethics, practical bias audits within a decision intelligence tool. So yeah, Toma, we can go to the next slide. So, okay, responsible AI, the guardrail framework, a system that works technically but create unfair outcomes that I was telling previously, and unexplainable decisions or unmonitored drift is not a system that can be trusted, of course. So because regulators need all the answers of all the decisions in any financial institution. So model drift means the model's performance quietly degrades over the time as fraud pattern change. Okay, because model is something, it's not now, learning about what is running behind the fraudster's mind. So explainability means being able to say to regulators in plain language why a specific decision was made. So yeah, so this is about the guardrail framework. Before the decision, data quality checks, identity validation, bias screening on input feature, fairness aware feature selection. During the decision, rules and ML scoring combined, confidence threshold enforced, human escalation triggers for borderline scores. And after the decision, audit logs retained, model drift detected via statistical monitoring, false positive rates tracked by the customer segment. So yeah, we can go to the next slide. So yeah, looking ahead, we see um, agentic AI taking over the heavy lifting of investigations and federated learning, allowing the DI tools to fight fraud as community without compromising privacy. So if you see agentic AI, autonomous AI agents that research suspicious entities and draft SAR reports automatically. So SAR means suspicious activity report. And then federated learning, banks sharing fraud patterns without sharing underlying PII data to build collective defense. And then graph neural networks, deep learning that natively understand that shape of a criminal networks for predictive detection. So yeah, we can move to the next slide. So data system decision trust. Data should be clean, connected, contextual. This is a non-negotiable foundation. Systems, it should be layered, governed, monitored, not just models, architecture, decision, it should be explainable, calibrated, owned, human and machine together. Trust earned through consistency, fairness, accountability, the real output of every system. So this is the chain that makes financial crime detection work. You break any link and the system fails in the form of missed alerts, blocked customer, and undetected risk. The goal is not to build AI. The goal is to build system that earns trust from customers, regulators, the people who operate them. So this is how, since we have covered all the slides now, Toma, I would like you to move to the second slide again because I want to just, revisit that idea so that people can relate to it. Yeah. So if you see here, the business goal, where I have mentioned the tactical and strategic. So tactical approach is in any organization is about identifying criminal activity and network in a customer database that pose a risk to the bank. And strategic is identify and understand and brief stakeholders on emerging financial customer threat. So I just want to tell you that how in an enterprise everything works, we ingest a lot of data, we transform it on the basis of how uh, a suspicious activity can be tracked. We transform it and we provide that to any tool. It can be a tool, it can be a in-house coding or ML or anything. So in this case, I have taken an example of tool. So we take the data, we transform it, we provide it to decision intelligence tool, and within this decision intelligence tool, we have certain identity resolution graph intelligence to identify the people and entire network, and it maps everyone, and it provides a result about how it can be an emerging threat to any financial institution and to the world, of course. So yeah, this is what I worked, in my previous organization, and I just wanted to share. And yeah, I'm done. Like, okay, thank you so much.
Thank you so much, Vijaita. That was a very interesting
Yeah,
session there. I think we'll just go straight into the Q&A. So if anyone has any questions,
yeah.
feel
Please let
free
me know.
to either
Yeah,
raise your hand or I can see a few thumbs up. Good job.
thank
Some
you, thank you.
applauses, claps. Thank you.
Yeah. Yeah,
Um,
please come up with questions. If I'm not able to
question.
answer, maybe I'll reach out. I mean, you can reach out to me on LinkedIn. I'll try to respond, as soon as possible. But yeah, this is my favorite topic, and that is why this is very close to my heart. So,
And
thank you, Annie.
before we go, I will just drop the feedback form again in the chat there. Please take a few minutes. It only takes like two to 3 minutes. Give us your feedback, what you think about the session, any ways we can improve. Um, while we wait for questions. I have a question.
Yeah, please.
So I was thinking, I have two questions actually.
Yeah,
First one, you walked us through that architecture, and I was like, just I think I even have like a mental picture, but let me go back to the slides there.
Yeah.
The different layers, which is quite interesting to kind of
Yeah.
have a holistic idea of, these systems that we are building. But
Yeah.
in your experience, right, what part of like the pipeline here do you would you say is most often like the bottleneck when banks or organizations are trying to get fraud detection systems into production? Like, where do you think like the issues arise, and like what are some of the kind of challenges that you've seen from your experience there?
Yeah, of course. And this is really a great question because I have been a part of data engineering team and I know the pain what everybody goes through. The most challenging part is the foundation layer, which is the data layer. Because
Hmm.
the data is siloed. I mean, you never know. The KYC data is different. The payment data is different. Everything is different. They are not connected at all. And every table has different kind of data. Like Toma, you have like suppose you have made some transaction in say dance store. Okay, so it have your particular transaction history is in another table, but how you
Hmm.
are connected to any other individual, that data, that particular data is somewhere else. How do we connect those things? So I think connecting all the silo data together is one of the toughest job that any of the architecture has. So I think foundation layer is one of the craziest and one of the most difficult part, because if data is correct, everything is correct. If data is wrong, everything is wrong. So yeah, that was one of the most challenging factor. And along with that, I would like to tell you, in any enterprise, when developer or any data engineer work, they don't know the holistic view of the project. They don't understand that where exactly this data is going and how exactly any tool is making out of this data. So
Hmm.
usually management, they don't tell developers that, okay dude, you are working for such kind of project. So they have no clue. They just know that, okay, there are two tables, I need to connect those. So this is one of the challenging thing in any organization. So I think if you are working or if you're a part of a big team, always ask your manager, sir, what is the holistic view? What is the big picture? Where exactly my data is going? So as to understand what I'm working on. So that's how you grow and that's how you make the foundation perfect. Yeah.
Fantastic. Yeah, I think I agree completely. And I think that is also a lesson that can translate into any sector, any industry. As you said, like the quality of the data you have will determine, your final um, model performance or output. So yeah, data is key here. Okay, interesting. Any questions, guys? Or are we all good? I think if we have no questions, we can call it a day.
All right. And
Um,
thanks everyone for your time. Really appreciate.
yeah,
And
thank you
Toma, of course, to you
again,
as well.
everyone. Thank you, everyone. A huge thank you to, you all for joining us over the past 4 weeks. As I said, Um, in the feedback form, we also have a place where, if you would like to speak with us at Women in AI, you can leave some of your details there and we'll get in touch. And we do have a few more series planned for the rest of the year. So, looking forward to having you join us again. Thank you, everyone, and enjoy the rest of your evening.
Thank you. Bye.